Hello and welcome to the second video for my October 2021 Retro Challenge project, which is the implementation of a Mumps interpreter on the ti994A computer, written in TMS 9900 assembly language. And if you're not familiar with Mumps or this project, feel free to check out the first video in the series on my channel. Now, I'm not a regular creator on YouTube. This is not going to be a highly edited video, but basically just sort of a live run through of the test suite of programs I use to validate that my Mumps interpreter is working as I continue to add features and functionality. So with that, let's get started. So as you can see here, I'm on my startup screen for the TI-99. I've got my Mumps cartridge already plugged in, so to speak. I'm running here today on the Classic 99 emulator, but all this runs on regular hardware as well. So I'm going to pick two to start Mumps, and takes me right into my Mumps screen. And I am going to load from disk the Mumps program I have that is used to exercise the system. So ZL is the load command in Mumps. So we're going to ZL from disk 1 and the mdemo program. So that's loading from disk, and now I've got this as a menu driven program. So we'll do the execute the command do menu, which will start the program, and you can see here it brings up uh, a menu into these different test programs. So every programming language has to be able to do hello world. So it's a very trivial example there of a simple printing of hello world to the screen. The next two menu options are a loop to display all the visible characters or printable characters in Mumps. And the reason I have two of them, one is at the very top of the program and will run very quickly. The other is all the way at the bottom of the program. And these loops are implemented with goto commands. And as you know, with interpreted language, a goto command has to scan the entire program to look for the line number, say in BASIC, or in this case, the line label in Mumps. So this allows me to see how well the interpreter is performing, basically with no restrictions with the code at the top. And then in this case, this program is about 3 or 4 K in length, and we'll see here the difference in speed to implement. So let's run the first one, which is at the top of the screen, and pretty quick, runs through, prints out all the visible characters that we have here. And now we'll do option 3, the ones at the bottom, and we can see it's definitely running slower. So this is the reason that when Mumps was created, they implemented for loops, because the for loop is able to hold on to the address of where the for loop starts and doesn't have to rescan back through the entire source code like a goto statement will do. So I've not yet implemented for loops into my interpreter. That'll be coming in the future for sure, as well as there's ways that the goto can also be improved, such as keeping a list of line labels and their addresses, which would be a lot shorter to loop through than all of source code. All right, next are the intrinsic functions, or sometimes known as the $sign functions. So let's take a look at those. I'm starting with setting the variable s equal to the string Easton the Diva Beagle. And if you knew my dog, you would understand why I chose that. But seriously, there's a few different intrinsic functions here. Let's go through them quickly. The $A returns the ASCII value of a character. So $A of S goes to the first character in the string and returns its ASCII value. So the dollar A of S with the capital E as the first character, its ASCII value is 69. The next way to use the $A is with the second parameter, which says give me the ASCII value from the string S, the 15th character, which is an A, and you can see that that value is 65. And then a second one, $A of S comma 2 is also an A. You can see that that's also 65. The $C function says, given a ASCII value, tell me the character. So $C of 65 returns an A. Nesting our functions, we've got the $A of S, which we knew was $A returns 69. The $C of 69 is the letter E. The $E function is extract. It says extract a character or a set of characters from the string. So $E of S says give me the first character in a string, and you can see it returns the E. The $E of S sub 12 returns the 12th character in a string, which is a D. Given two extra parameters, $E of S, comma 8, comma 16, gives the A through the 16th characters. Next is the $L function, which is the length of a string. So $L of S returns 22. The $L of the $E of S, comma 8, comma 16 returns 9. Another example of nesting the intrinsic functions here. The final one implemented so far is the $piece function. This gives a substring delimited by the character in double quotes. They're showing only a single quotes here for display purposes, but you would type in double quotes. So $piece of S, comma space in double quotes says give me the first piece of the string delimited by a space, which in this case returns the string Easton. Give me the $piece delimited by space. The third piece goes through the string and looks for the third string delimited by the space character, which in this case returns the word diva. All right, next I have a short program that will exercise the reading and writing to disk files. So the first thing it does is asks for a file name. So we'll put in disk1.test, and it'll go through and open the file, write a line of text to the file, close the file, and checks all the return error codes for that. And then once that's been completed, it reopens the file for reading, reads the line, types the record read, and then closes the file to make sure, again, all the codes are written. So not very exciting here on the emulator, but when run on my real hardware, ti994A, along with the peripheral expansion box and the disk drive, I can see and hear the disk drive go on and off and ensure that information is truly being read and written to the disk file. All right, next, a quick demo of working with arrays. So each of these strings here printed on each line is information placed into an array, and then the arrays loop through. This allows me to check that my code for storing arrays to memory is working. And just as a note, in Mumps, variables and arrays are stored in binary trees, which allows for very fast retrieval. Whereas, as an example with BASIC, those are typically just stored sequentially in memory, and the interpreter has to loop through the entire symbol table until it finds a variable. Whereas with Mumps, the binary tree has gone through, and variables and array values can be found very quickly. All right, nested loops. So this again is just a little bit exercise. Two nested go-tos. One looping from 1 to 5, the other inside looping from 1 to 3. And again, it just is a good test of my variables being set, loop values working, if statements working, go-tos working, and so on. Math. So math in Mumps is a little bit different than in other programming languages. So certainly from a operations perspective, addition, subtraction, multiplication, division, modulo, or remainder of division are the key math operators that have been implemented to date. And I've only implemented integer math so far. But the key thing that makes math different in Mumps is that it's always interpreted left to right. So there is no precedence in operators. So in the first example down here, 12 times 4 plus 2 divided by 5 occurs exactly in that order. 12 times 4 is 48, plus 2 is 50, 50 divided by 5 is 10. If you want to implement precedence, parentheses can be used. So here we have 12 times parentheses 4 plus 2. So 4 plus 2 is 6. That happens before the multiplication. 6 times 12 is 72 divided by 5 is 14 with the remainder of 2, which is not shown here again. Integer math has been implemented to date. Operators also work a little differently in Mumps. So we have equals, greater than, less than. We've got string, checking for one string following another, or equality of strings. And these all return either a 1 or a 0. So I can write the value of an equality test or greater than or less than test, and it returns the value 1 or 0. Also down here below, we can see we're looking at checking the value of two characters. We're using our $E. We've got a string up here, WS, which is world. Another string, HS, here is hello. So we're looking at the second character in WS, which is the O, and the fifth character in hello, which is also an O. So if I say ask if the two are equal, I get a 1 in return. There's also a concatenation operator. So I've got HS concatenated with space, concatenated with WS, which returns the string hello space world. And then ifs and elses in Mumps work off of a system variable called $T. So for example, here I have if 1 equals 1, 1 equals 1 is true, that sets the $T equal to 1. And in that case, anything additional on this line would be executed. If n is greater than m, n is 99, m is 100, so that is false. $T is set to false. And also then nothing else on this line would be executed. We jump down to the next line. And in that case, if the next line is an else statement, an E, so an else, it does not take any parameters, else space space, else only looks at this $T value. And if the $T value is 0, then it executes what's on the else line. Otherwise, if $T is true, else does not execute what's on that line. All right, so that's the set of things I look at in terms of is the Mumps programming language looking okay. I've also got some additional tools here that are helpful. I've got them on the menu here, but these are also all available from the Mumps command line. The first is a RAM monitor, so I can go in and look at the contents of RAM or ROM, what's on the cartridge. So for example, if I want to look at the space where my registers, software registers are located along with the other 256 bytes of pad RAM. If you're familiar with TI-99 programming, that's all the RAM you get without expansion. And that's where I've put a number of system variables, such as the start of source code location, current top of source code location, where my symbol table indexes start, where the symbol data starts. So those types of things are in this area. And it's just a simple monitor that allows me to go in and look at what's going on. For example, here 8330, this line, this third set of bytes is the starting address of the indexes to the symbol table. And down here at 8390, this is actually where I'm housing some what they call trampoline code that allows me to bounce back and forth between banks in my ROM cartridge. So I can take a look at the second set of bytes and know that 6002 corresponds to bank 1, which is where I know that this ROM monitor code is sitting. All right. Let me jump down to list variables first, and then I'll display the program. But list variables. This prints out all the variable names that are in the symbol table. I don't know how many times in BASIC I would have loved to have something like this to know what variables I had created and already have used. So this ZW, which is the command you would use from the command line, shows all the variables that are in fact in the symbol table. And then finally, D display program. This is just the listing of the Mumps source code that's in RAM, and this is all the code that we've been running here to see this test suite of programs. So I'm just gonna scroll through. There's our arrays being set up. Here's the code that prints out the menu and takes the menu selections and so on. So that's about it. I can quit out of here, and I'm back to the mumps prompt. One additional feature of the display, if I wanted to go display a certain line label in my source code, like ZD menu, I can go in and start at that line label, and it will scroll through the rest. Certainly, I want to add here the ability to page forward and backward, like I have in the monitor, and do some also maybe do ZD menu to bars, so I can only have to look at a subsection of the source code. All right, finally, to when you're completed mumps, H is the halt command, and that's what we use to stop mumps and take you back to the login prompt, where you can certainly go back into basic, back into mumps, or just be done for the day. So I thank you for your time watching this video. Hopefully this helps understand my approach to working on building this interpreter and how I can continue to test it as I go on. Thank you for your time and have a great day.